Good evening, everyone. A warm welcome to all. I'm Dr. Juhi Yasmin, Assistant Professor of Communicative English, Department of CSE, AI and ML, and Cybersecurity, Faculty of Engineering and Technology at Jain, deemed to be University. I'm here to welcome you all to today's Industry Connect session. Today's session is on cybersecurity, and the title for the session is Application Security. For this, today we have with us an esteemed guest speaker, Mr. Alex Varghese. He has over 10 years of professional IT experience in application security, security development, life cycle, risk management, infrastructure security, and vulnerability assessment using OWASP, NIST, and CWE/SANS special publications. He is the one who ensures that the corporate-wide security and compliance requirements are met across all systems and data for the enterprise. At present, Mr. Varghese is working as the cybersecurity architect at Schneider Electric. His area of expertise includes application security, risk management, IAM and N/W security, vulnerability management. And on behalf of entire Jain family, sir, I would like to extend a warm welcome to you and thank you for taking out your precious time to be spent with us. Today's audience is the students of B.Tech Cybersecurity, BCS students, as well as our faculty members of the same department. Now it's over to you, sir. Please start the session.
Thanks, Juhi. Thanks a lot. Thanks all for joining this session. Thanks, Juhi and the team for giving me a wonderful opportunity to present something about the application security. I will explain about my expertise areas, why we need application security, and what all the things that we need to be done while we perform an application security. So once again, thanks all. I will just present my screen. And about my presentations, my slides are very less in number. Because I need this to be an interactive session. So you can stop me at any point of time. You can give your thought process, everything. So we will brainstorm and we will do, I will explain my expertise and we can do a brainstorm sections to make it as an interactive section. So with that, can I start my presentation?
Sure, sir. Please go ahead. Please go ahead.
Please let me know once it is visible to you.
Okay, sir. Just start sharing.
I have started sharing. Hope this is visible.
No, sir, not yet.
Okay. Hope now it's visible.
Yeah, sir. Now it's visible.
So before I start, I will give a just introduction about myself. My name is Alex Varghese. I'm working as the cybersecurity architect for Schneider Electric. So I will be focused on application security for the industry automation. So most of the people may be knowing industry automation. Some might not be, or might be hearing it for the first time. So industry automations, we will be dealing with a lot of products like HMI, IIoT, IoT devices to automate the industries across the world. So we will be having the hardware applications and software applications, and I will be designing the security, cybersecurity controls and the architecture across these products. So this is all about me, and my overall experience will be around 11 to 12 years of experience, and I do hold the below mentioned cybersecurity certifications in the industry. So before I go more into detail, so I will just give a glimpse about what all the things that I will be taking about or I will be talking about on this session. So we will be primarily focused on application security. So why we need application security, what are the outcomes if we are not performing the application security. So most of the students, I guess, are from B.Tech and BCA, computer science, right? So most might have gone through the software development life cycle. So how we can incorporate the security into each and every life cycles of the application till the disposal phase. So these are the things that I will be walking through today from the application security standpoint. Don't expect any security labs or a security tool. I will not be performing any security analysis or vulnerability analysis in this. The reason is that all these tools are licensed, so I will not be able to perform a live vulnerability analysis or application security control analysis in this session. Hope the agenda is clear. Without much delay, we can start on. So my first slide will speak about why we need application security and principles of application security. So before we go to application security, we need to understand why we need an application for an enterprise level or for a business. So when basically we need an application whenever there is a business use cases or whenever there is a business hindrance, people will be focusing on resolving this business hindrance. So this business hindrance can be resolved by in certain cases by developing an application. So this application will perform or will be working as per the use cases or the end user analysis, and it will be delivering the things in order to solve that business use cases or the business problem. So this is the reason why enterprise levels or the organizations has developed applications from in-house applications or an outsource application. So these applications can be spanned across. It can be a desktop-based application. It can be a web-based applications. It can be a mobile-based application. So the diversity of the applications across the industries has grown a long way at this particular moment of time. So that's the reason why the organizations or the enterprise levels develop the applications to solve the business cases. But in one side, it will be solving the business cases, and if we are not incorporating the security into these applications, then it will be a very big mess for the organization, because it can lead to the asset loss, a threat, and the vulnerability can be exploited, and the data or the entire application or the entire organization itself can cause a very impact on these factors. So that's the main reason why we developed a concept known as left shift. That means we will be building the security from the first phase, and we will be following the security till the last phase of the application. So that's the one of the primary reason why we need the application security, or application security is incorporated into the applications that we developed. The second thing is that now there is a concept which is known as SD3 principle. It means that secure by design, secure in development, and secure by default. Secure by design in the sense that we will be designing an application from the business standpoint. Secure in deployment or secure in development means that we will be developing applications and deploying the application in an eco structure, which will be intercommunicating with a lot of discrete systems to provide the intended solution. Secure by default means whenever we develop an application, it should follow all the security principles to make sure that the application itself is in a secure mode by default. So these are the three principles that we are incorporating from the security standpoint from the beginning of the application development. The fourth reason why we need application security is that every organization will have assets. The assets can be tangible and an intangible asset. So assets basically classified as something that add values to the organization. So it can be a data, it can be a server, it can be an application which adds value to the organization. So the primary aim for application security or the cyber security is to protect the assets that are tangible or intangible to the organization and which add values to the organization. So from this standpoint, any one of you have any questions or any much clarity needed from this standpoint? Hope things are clear. So now we will speak about the principles of the application security. The principles of application security revolves around 3 R's, which is basically known as reliability, resiliency, and recoverability. So reliability means that we will be making sure that the application is functioning as expected. For example, uh, say we have an organization X and we are selling some products online. So we have an e-commerce website. So imagine a scenario that this X organization is selling out food for the customers or the end users. So the intended use is that the customers or the end user should be able to log in into the application and order the food that they need, and our organization should deliver that food. So that's the basic reason why we check out for the reliability, whether the application is providing the intended functionality which can create a business value to the organization. The second thing is that the resiliency. Resiliency in the sense that whenever a cyber attack, whenever we implement an application, the application is holding the security controls in order to withstand the attack if an attack get materialized. That means the e-commerce application should have the security controls to protect the confidentiality, integrity, and availability of the data or the resources that are inside this particular application. Recoverability means, say, this particular application got hacked, or a attack has happened to this particular application. It should be restored back into the normal state, which can provide the operations of the application to add again the business value. So that means the application should be restored back to the normal functioning. So these are the three main principles of application security, which means reliability, resiliency, and recoverability. So I'm just pausing for a couple of seconds. Does anyone of you have any doubts or any questions regarding this? Hope I can continue, right?
Yes, sir, you can continue.
Okay. So
Because
when
for the doubts and discussion, we'll have in the end, like for 5 or
absolutely,
10 minutes for that. Yeah,
absolutely,
so please continue.
absolutely.
Thank you.
So when we speak about the application security or the software security, the security is divided into two pillars. One is known as the core security concepts, and the second one is known as the design security concepts. So the core security concepts, it can be classified as confidentiality, integrity, availability, authentication, authorization, accountability, and auditing. So most of you might be knowing about confidentiality. Confidentiality is putting out the security controls into a system to prevent the unauthorized disclosure of the data or the information. That is meant by confidentiality. So the confidentiality can be provided by a lot of techniques. One is known as the encryption. The second can be known as the hashing. The third can be the watermarking, or the fourth can be a steganography. So this is known as confidentiality. Integrity means putting out the security controls to protect the unauthorized modification of the data or the information. So one solutions can be the hashing, can be implemented in order to provide integrity. Checksum can be the another solution that can be provided to protect the integrity. So availability means, which is one of the another core security principle when we speak about the security. Availability is providing the systems information or the data to the right person at the right time. So this can be established, or this can be accomplished by implementing the security control solutions like backup, load balancers, other recovery solutions. So the next three things, which is known as authentication, authorization, and accountability, is basically known as IEEE. So there is one more thing, which is known as identification, authentication, authorization, and accountability. So authentication is that, say, whenever you give a username and password, it is verifying the authentication credentials in a database to check whether the claimed identity is a genuine one, whether there is any impersonation is happening or not. So that speaks about authentication. Now, a secure method of authentication is providing the multi-factor authentication by combining the factor one, factor two, and factor three authentication. So when we speak about factor one, it is known as something you know. Factor two can be something you are, something you have, sorry. And the factor three will be something you are. So something you know, it may be a password that we put normally, or it can be a fast phrase that we put normally. Something you have, it might be a OTP, it might be a smart card. Something you are can be your biometrics like fingerprint, retina scans, biometric scans like that. So that is meant by authentication. Authorization means, and authorization will not go above authentication. After authentication, only the authorization will happen. So when we take the systems level, it can be classified as two things: subjects and the objects. Subjects are the human beings or a system that try to access a resources. So these resources can be classified as the object. So authorization is the method in which we grant the permissions and the rights for the subject to act upon an object. It can be a modified action, it can be a delete action, it can be a copy action. So for permitting these type of rights and privileges to an object to act against an object is basically known as authorization. So accountability is basically known as the non-repudiation. So we will be having the security controls to provide non-repudiation. That means, so imagine I am sending an email to Juhi, right? So I have an email address, I have an authentications method. If I send an email to Juhi, I will not be able to deny that factor, right? Because I cannot be, I won't be able to say that it was not sent from my end. So that is meant by non-repudiation, a security control to prevent the denial of an action. Auditing means, say whenever an action performs, it needs to be audited for two to three reasons. First will be for the troubleshooting. The second reason will be for the policies and the standards, and the third thing can be from the regulatory compliance. So auditing means it can be act as a detective control. So whenever we act upon an action, it should be triggered and it should be noted who performed and why, when it has taken place. So that's about the auditing. So these are the core security principles when we speak about system or an application security. So now moving out to design security concepts. So the design security concepts are a little bit more when we compare from the core security concepts. So it can be least privilege, it can be separation of duty, it is defense in depth, fail safe, economy of mechanism. So I will explain each one of them. So least privilege in the sense that, so whenever we gain an access like an authorization, we should be given access in a method, say that we should be given access in order to perform whatever the things that are required from our job role perspective. So imagine a scenario that I am a server administrator, L1 server administrator, in which I will be able to perform whatever the things that are required from my job role perspective. So imagine a scenario that I am a server administrator. L1 server administrator, in which I will be able to perform whatever the things that are required from my job role perspective. So imagine a scenario that I am a server administrator.
Meeting is being recorded.
So once the cashier or once the cash teller thing, and she will be sending out to the assistant manager to approve that one. So that is basically meant by separation of duty. It is basically done to avoid a concept known as collusion. So defense in depth is known as a strategy, which is also known as layered security control. So even if one of the security control is circumvented, there will be a lot of security controls in a layered method to protect the asset. So for example, placing a firewall, placing a WAF firewall, placing a normal network layer firewall,
Mr.
the identity.
Alex Varghese,
Okay.
sorry to interrupt you. We couldn't see your presentation.
Oh, okay, 1 minute. It was visible right before.
Earlier it was, but
I think someone has stopped and started the recording. That might be the reason. So now it's visible, right?
okay. Now it's fine. Now it's fine. Great. Go ahead.
Okay. Defense in depth in the sense that, okay, it will be a layered defense. So placing different security controls in a layered or a serious method. So the basic agenda behind that is even one of the security control is circumvented, there will be another security control to protect the asset. So basically placing a WAF, placing a network layer firewall, then placing the IAM security controls to protect the assets. Even if the WAF is circumvented, there will be the network layer firewall to protect that. Even if the network layer firewall is circumvented, we have the IAM security controls to protect the assets. So fail safe in the sense that whenever there is a failure of the application's infrastructure or the system, it should protect the confidentiality, integrity, and availability. So we can take an example. We have a firewall. So in some of the reasons, the firewall itself might get failed, right? It can be used as software corrupt, or the hardware itself has got failures, right? So at that point of time, it should be in a default fail-safe method, in the sense that it should defaultly be deny all. It should not allow all. It should not come into the allow all. That means whenever a traffic hits, it will deny, whether it's a rule or not a rule inside the firewall. That's basically meant by fail-safe. Economy of mechanism means, in simple, we can say that keep it simple. So whenever an architecture is designed, the architecture should be simple enough so that we can make sure that we are not increasing the attack surface, vulnerability, or weakness inside the system. So economy of mechanism means that it should be simple and it should be efficient enough to serve the business need. Then the next set of security control from the design security concepts are complete mediation, open design, least common mechanism, acceptance, and leveraging the existing components. So complete mediation in the sense that most of the people might have heard about a concept known as security ZTA, zero trust architecture. So whenever an access request comes, whether it will be completely mediated. Every time it will be checked, whether it's a 1 minute before request or a 1 minute after request. Every time the request will be checked, and it will be checking out the parameters. And whenever it validates the parameters, then only the access will be given. So whether it's a valid user or an invalid user, all these parameters will be checked each and every time. So that is meant by complete mediation. Open Open design means that our designs, most of might have heard about the Kirchhoff principle, stating that okay, the algorithm can be, the encryption algorithm can be open and be in public, but the secret keys should be protected to provide the security controls to the organization. So least common mechanism, in the sense that no one should be using the common mechanism. Say, for example, we have a database in which we hold the employee details like the name, last name, first name, and the salary. So a least common mechanism should not be leveraged, so that a person with the admin privileges can pull out the data as a username and last name, which can be a public data inside the organization. But the compensation part will be a private or a sensitive data. So you leveraging the common mechanism, he should not be able to get the data with one single command. So that is basically meant by least common mechanism. So acceptance, in the sense that okay, whenever we implement the security control, it should not hinder the functionality. It should be easily usable. It should be easily accepted. That means it should not hinder the functionality, or it should not provide any lag to the applications or the business application. So it should get an acceptance of the security controls when we implement it across the application. So leveraging existing components means, say, we have an application and we need to encrypt the data inside the application. It is better to use a proven technologies or algorithm of an encryption algorithm rather than building a new one from our end. So building a new one from our end will cause many vulnerabilities and the weakness that can go undetected, and in the end it can cause a breach or an attack. But if you are using a well-established algorithm which has gone a lot of testings and lot of certifications and the validations, we can make sure that this particular incorporating this particular encryption, it is not involving, or it is not bringing in new vulnerabilities or weaknesses into the system. So this is more about the core versus the design security concepts in the application security or a system security that we should follow. Now we will move on to the next phase, which is known as the secure development life cycle. So most people might be knowing the secure development life cycle or the software development life cycle flows through different phases. So it comprises of the requirement phase, then it moves into the design phase, then it moves into the development phase, then testing phase, verification, validation, certification, accreditation, deployment phase, operation and maintenance, and finally the disposal phase. So we will look into each of these phases. What are the security things that needs to be done in each of these phases? So first we will take about the requirement phase. In the beginning, I have said that, right? When a business needs an application, it is basically developed to solve the business cases or the business problems, right? When we speak about in the requirement phase, we will build a requirement traceability metrics. The requirement traceability metrics will consist of three components. First one will be the functionality requirement, which are needed to solve the business problem. The second thing will be the technical components that are needed to provide the business requirement, or that are needed to serve the business requirement. The third thing will be the security requirements that needs to be incorporated to protect the business assets and the technical things that we are building in the application. So for example, we are building an application, as I said, which will be an e-commerce application that will be serving the food across the area. So the functionality requirement is that okay, all the food items should be listed. First thing. The second thing is that people should be able to place orders based on their taste. The third thing is that they can do an online payment or a cash on delivery payment or anything like that. The fourth thing is that the food should get delivered in the correct time at the correct place. So these are the functionalities, minimum functionality. So we have fed this particular functionality requirement into the requirement traceability metrics, which is the first component. And the second component will be the technical requirement. So it can be a mobile application or it can be a web-based application, the first technical component. The second thing is that we need a database, right? We need to hold all these food items in a database. So that I'm just saying about the minimum requirements only. So this might be the technical requirements, right? Now comes into the security requirements. What are the security requirements for the same? Okay, so the security requirements should be considered from two facts. First will be the functionality requirement and from the technical requirement. So basically, functionality requirement, we are providing the online payment, right? So we will be saving the PFI data personal financial information, which can be a credit card data, which can be a debit card data, or other, these type of data. So when it comes into the technical requirement, it can be a mobile application or it can be a web-based application that needs to be in the internet. So these are the security requirements that we can take from the functionality and the technical aspects. And the second security requirements will come from the policies and the regulatory compliance. Okay, imagine we are trying to serve this particular business in Europe region. So we will be collecting the PII, personally identifiable informations of the European citizens, right? So it comes as the regulatory compliance to protect the PII data of the European citizens as per GDPR. So that is also one of the security requirements. So all these data will be fed into a component which is known as requirement traceability metrics that we will be developing in the requirement phase. So in the real-time scenarios, we have a lot of applications like ECRQ, which will serve this purpose. Other times we will be maintaining those requirements in an Excel sheet itself. So this is the security things that we basically do in the requirement phase. Now it moves into the design phase, right? Yeah, so when we speak about the design phase, all these requirement phase, all these requirements that we gathered in the requirement phase, the functionality requirements, the technical requirements, and the security requirements will be crafted out into an architectural diagram. So it is basically done by the software architects. They will be placing all the components. It can be a web-based web server. It can be a database server. It can be an application server. It can be a DMS at SON. It can be a firewall. It can be a data flow path. All these will be crafted as a high level diagram and a low level diagram by the security architects to serve the business purpose. So now what will be the action of the security architect or a security advisor? So we are responsible for performing the attack surface evaluation first thing, and the second thing will be the threat modeling. So when we speak about the attack surface evaluation, we will be checking out the entry and the exit point of these applications, and we will be crafting out what type of attacks that are possible inside the entry or the exit point. For example, if the user doesn't have the proper authentication mechanism, a impersonation can happen, a spoofing attack can be happen. So these type of mapping, attack surface mapping will be done, and we will be placing the security controls to mitigate those particular things. The second thing that we do in the design phase will be the threat modeling. So threat modeling means the architecture, the software architecture that the software architects developed is decomposed into different parts, right? So it will be decomposed into an entry point. It will be decomposed into an exit point. It will be having a trust boundary. Then it will be having the data store. It will be having the data flow paths. All these decompositions will be done. And basically, it is done using a Microsoft Threat Modeler tool. And we apply a methodology which is known as STRIDE methodology. If you go for the expansion, STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of services, and escalation of privileges. So as I said, in the threat modeling, we will be decomposing these particular applications into different parts, right? So in the entry point, we will be applying the STRIDE methodology, whether there is any vulnerability that is existing in the design phase, to understand whether a spoofing, a tampering, a repudiation, information disclosure, denial of services, escalation of privileges activities are possible or not. If possible, we will be providing it with the proper security controls to mitigate the same. For example, if spoofing is possible, we will be providing a strong authentications and the authorization mechanisms. So as I said, it can be a web-based application, right? If you are not using the HTTPS protocol, tampering of the data or stealing of the data can happen. At that particular point, the tampering is possible, and we will be mitigating those risks using the HTTPS, which is one of the secure transfer protocol, right? So these type of STRIDE methodologies will be applied to each and every decomposed part. It will happen to the entry point, it will happen to the exit point, it will happen to the data store, it will happen to the data flows, and it will map the threats and the vulnerabilities that are existing in the design. And the security architect, in collaboration with the software architect, will be developing the security controls across the design to mitigate all these vulnerabilities that are notified or that are detected by this particular tool. So now we move into the development phase. From a security architect or a security advisor perspective, we doesn't have much hands-on things to do in a development phase, because coding will be completely done by the developers. So what we can do is that one is the security awareness things that we can give into the developers to practice the secure code development practices, like avoiding the infinite loops, avoiding cyclomatic complexity. The third thing is that avoid hard coding of passwords or the configuration things inside these particular application codes. The fourth thing is that do not place any backdoors inside the application, to make sure that whenever the application is not running, they will be having an entry point which is not completely monitored by our security system. So these are some types of security controls that can be practiced in the development phase. But other things that we can do from the security standpoint is that we can we can integrate a SAST tool inside the development phase. SAST tool means static application security testing tool. There are a lot of tools like Veracode, 45 checkmarks that can be integrated into our application development module. Like in .NET we use the C# and everything, right? It can be integrated into that particular module. So whenever a developer practices a improper secure coding way, it will get auto detected and it will trigger an alert to the developer stating that okay, the best security practices, coding practices are not being followed, and it will provide the mitigation controls that needs to be followed by the developer to mitigate those risks associated with the code sourcing. So now we move into the next phase, which is known as the testing phase. So in my earliest slide, in my first slide, I think I have spoke about the reliability, resiliency, and recoverability. So testings will be done on all these parts: reliability, resiliency, and recoverability. So as I said, reliability will be checking about on the functional part, whether the software is functioning as intended for the business use cases or the end users. So basically, those type of testing involves the unit testing, the logic testing, the regression testing, and the integration testing. So unit testing in the sense that the software will be, it is mainly performed by the developers, in which the software will be developed in modules, and each module will be tested to find whether there is any code errors that can hinder the functionality of the application. So when we speak about the integration testing, as I said, each developers will be given each modules, right? So all these modules will be integrated, and we will be testing whether there is any failures that is happening when it is getting integrated. So regression testing will more speak about say when we will be developing different versions of the release of the applications, right? So regression testing will make sure that the new releases is not bringing upon the old errors or old bugs that we have already fixed in the application. So these type of testing will be completely done from the reliability perspective. Now we move on to the recoverability perspective. We will be performing the performance testing, in which we will be checking out the load testing and the stress testing to understand at what point or at what operational point will the software will break. So imagine a scenario that we need an application for 32 GB RAM. So we will be giving the concurrent or the concurrent processes which needs to take about 36 GB. So what will be the application responses in that particular point of time? Now another testing that can be performed from the recoverability perspective is scalability testing. So scalability testing in the sense that, say, when we speak about the cloud application, the cloud applications has a feature that, okay, so for 32 GB, we have given the default setting as 32 GB RAM. So if the applications or if the system is utilizing needs more RAM, it will auto scale to 36 or 40 or 50 GB. And once the resource utilizations get over, it will scale down to back to 32 GB. So that type of scalability will be there, or it will be it is possible or not. So those type of testing will be done in the recoverability testing phase. And finally, we move on to the resiliency testing phase. In the resiliency testing phase, we will again perform the SAST analysis, static application security testing. The other thing that can be done is the DAST analysis, dynamic application security testing. So the main difference between SAST and DAST is that SAST is performed on the source code. We will be having access to the source code. So it is commonly known as white box testing or a full knowledge testing. Before, the testers will have the full knowledge about the application and the source code. So when we speak about the dynamic application security testing, it is also known as the zero knowledge, because the testers will not have any knowledge about the source code or the application. It will be tested on the runtime. Some of the tools that are basically used are Nextpost, Nmap scans. Those type of things can be done in the task. And the other type of resiliency test as a part of assurance testing that we do are vulnerability analysis and pen testing. So basically, pen testing is done. So whenever a vulnerability is detected, whether that vulnerability exists or how it can be exploited. So those type of testing also happens in the resiliency testing. So from there, we come into the next phase, which is known as verification, validation, certification, and accreditation. So certification and accreditation specifically means testing out of the security controls from the technical standpoint, and accreditation is from the business standpoint. So the business will be approving this particular application to run in the production phase. So that is basically done for the certifications and accreditation. And then we move into the deployment phase. As I earlier said, these applications will not work as a standalone application. These applications will be deployed inside an echo computing environment in which it will be integrating, or it will be talking with a lot of discrete systems to provide the business use cases or the business functionality. So by installing our developed application, we should make sure that this application is not violating any of the security controls that we have already deployed in the deployment of the production environment. So that means, say, for example, in the deployment phase, we have already disabled the port number 80. So by installing this particular application, it should not enable port number 80 until and unless it is required. So it is not violating, or it is not triggering any other security weaknesses inside the system, is completely done in the deployment phase. Now we move into the operations and the maintenance phase. It will be mainly speaking about the patch management. So whenever the applications have some vulnerabilities, the hot fixes and the patches should be released to fix the application vulnerability, first thing. The second thing is that the problem management will happen in operation maintenance. So whenever there is an incident, the root cause analysis needs to be done in order to understand what has caused the problem, and a proper problem management along with the change management needs to be done in order to make sure that the problem is addressed and it will not occur again in the production environment. And finally, we speak about the disposal phase. So disposal phase is the phase in which the business doesn't request the application anymore. So in this particular phase, we should look out on a particular thing which is known as sanitization. So this particular application might be holding a lot of data. So a proper sanitization needs to be done so that we should make sure that the data remnants. That means once the data is deleted from the system, it should not be recoverable at any standpoint. If it is recoverable, it can basically cause an unauthorized disclosure of the sensitive data, which can be again a very pain point to the organization. So these are the different phases about the software development life cycles and the security things that we can do in different phases of the SDLC. So with this, I have come to the closure of the application security. I know that I have just gone through the theoretical part. I'm happy to present the practical part, but due to certain licensing issues or the intellectual property issues, we will not be able to perform a vulnerability analysis or a live pen testing on any of the applications that we have developed. So that's it from my end, Juhi. Yeah.
Thank you, sir. And now the session is open for the discussion and question. So if anyone has any doubt or queries, they may ask.
Yeah, absolutely.
I think, sir, with your lecture, you have already clarified everything. So there's no doubt from our
it's a big topic from the application security standpoint, but because of this time constraint, I will not be able to cover each and every point in a detailed way. I can just give an overall, but if we get more sessions, we can just go into each and every phases, and we will try to demonstrate what are the things that we do in the real time. But it's quite difficult. The reason is that some of the tools are licensed, so we will not be able to utilize those tools in a public domain. So that's the main problem.
Yeah. So Just thank you, sir, for such an enlightening session. And now, on this note, we have entered the final moments of our session, where I feel privileged to propose a vote of thanks. First of all, I would like to thank our Department of CSE, AI and ML, and Cybersecurity, and Futurance Technologies to conduct a wonderful event of Industry Connect, where our students with faculty members are fortunate to connect with eminent industry experts of various domains. On behalf of the Department of Computer Science and Engineering of Jane deemed to be university and all the students, I extend a very hearty vote of thanks to Mr. Varghese for accepting our invitation and for refurbishing our students with the best possible upgraded education. And I must mention a deep sense of appreciation to our beloved HOD, Dr. V. Vivek, for his constant support and motivation. I sincerely thank our team of very motivated and hardworking faculty members to join the session. Finally, I would like to thank our students for paying their valuable attention. Once again, I would like to thank you all for joining the session. Thank you.
Thanks, Yogi. Thanks all for joining the session. Have a great day.
Thanks.